All right, ladies and gentlemen, good morning to you guys. I hope you guys are doing well. Give me a like if you can hear me. Hopefully, you can hear me. At least on my end, it says you can. So let's write this down. Good morning. All right, likes coming on in. Thank you guys so much. Let's head on over to the browser. Let's check our internet speed, see how we're doing. We should be doing pretty good. And ladies and gentlemen, it's the upload speed we care about. So let's see how that turns out. And ladies and gentlemen, at 39.2, we are more than 3 times what we need. So set YouTube to 1080p to maximize your experience. Now, let's go on over for a few things here. Let me actually let you guys know something here. If we go to the schedule here, as you guys can see, you have test 4 on Monday, December 6th. All right, so it's on Monday, December 6th. Now, following that week, you have your final, a very week later. So you might say, hey, what's going on here with that? Well, here's what I'm going to do. I'm going to give you your test 4 as a take-home test, now. And you go, what do you mean now? If I go here to the file portion here, I uploaded this here. It's kind of I'm going to probably relabel that test 4 and then send you a different study guide. So I have to relabel things, ladies and gentlemen. So I apologize for that. Send you a different study guide, but as soon as this kind of thing goes through, come on, Canvas. Well, anyway. So we'll give it to you now. And what you should see here, hopefully, as Canvas starts to, there we go. We're going to start to see some questions that we're going to cover here. Area between curves and so on that'll come up in our future. Integration questions, differential equation questions, numerical, approximation questions here. No, my speed seems to be okay. Let's actually kind of look at that here. Volume questions. We have to talk about these things. That'll be next week. And so some of these things we're going to cover next week, but I'm going to give it to you guys now, some of these questions in anticipation, so that you guys know that this is going to be due in actually the 13th. So this test 4, even though it's scheduled on Monday, it'll be due the next week, the 13th for you guys. And that'll be partly a preparation for your final. There might be a few other different questions. Your final's not going to be at all as long as this. It's not going to be definitely not as long as this, but it's designed to get you guys some work in so that you can actually prepare for that final. And, I'll give you a study guide for the final as well, prior to the final. But ladies and gentlemen, this is what's going on for now. So I want you guys to know, yes, test 4 is scheduled for Monday. We're going to have lecture that day. We'll have lecture that day. So I'm giving you this test 4 now to get started on, and some of the things, you're not the trig class, right? You're the calculus class, but you guys want to get started on some of these kind of questions here already, and you could do some of them. But next week, starting tomorrow, you'll do some more of these. Starting today, we'll do more. But, this is coming. So, ladies and gentlemen, I wanted to give it to you guys now, give it to you early. It's going to be partly your study guide for your final as well. And your final exam is not going to be as long as anything like this. So I hope that's clear for you. I'll send an announcement to put it in writing in case it isn't clear. And yes, of course, I don't have any meetings today, thankfully. So we have some office hours in case you guys have questions. And we're going to continue with what we've been doing. We're going to continue, ladies and gentlemen, with all of this. Okay, now, just to kind of remind you guys here. Oh, thank you. Thank you. Good question. Homework still due next week. Um, yeah, I think you want to make sure that homework portion is due. And you don't leave it to the last second. Absolutely, Griselda. So that would be a good point that you're making. Make sure that homework it does get in so it's not postponed and it piles up, So you might want to do that as well because it's designed to prepare you for everything, whether it's test 4 or your final. So yeah, you still want to make that due so that it doesn't, you don't procrastinate on that. That's to kind of help the procrastinators. And our internet speed is still pretty good at 39.6. It's actually better. So I ran that, Canvas might be stalling, but not my end for broadcast. So we're pretty good here. So we want to look at a few things to get started today here on more U sub. But it's U sub now with limits. So, what we showed you yesterday, if we go over to, our website. Nope. Not that class. Calculus class. We're working with the substitution here. Integration by substitution. But this time we're going to look at the limits now. And like I gave you guys yesterday, if you wanted to look at some more examples here, I have, almost 3 hours worth of examples for you guys. If you wanted to do that, you get extra if you like. So that's still there. But now let's look at this U sub with limits. So it's not that, it's not that different. In fact, we just have to accommodate the limit now. So you might have, for example, to integrate from 0 to pi, and they may say secant, well, let me be careful. Right? They may have x squared cosine x cubed minus 1. Okay? Write that down and give me a few seconds here. All right, I'm back. I'm just saying a little hello here to little Melinda Judge. She's waking up. I'm going to miss seeing her when we get back to campus. Not so happy to get back to campus, but okay. Have mixed feelings, probably like everybody else. Mixed feelings. I'll be recording the lectures. I think I'm going to try to record the lectures for like Calculus 2, in case people didn't know. I think that's been very, very helpful for all my classes during this pandemic. And, if I have to record them and upload them at the end of the day or the middle of the day, I'll do that. So at least people have copies of the lectures. But anyway, yeah, going to miss seeing my daughter when she wakes up. Anyway, so take a look at this question here. This is kind of an interesting question. Yesterday we discussed that idea of integrating here by using U substitution because when we have a composition of functions here, right, we have to use U sub. And U, remember, is always that inside function. So we let u here be that inside function. This was the u from yesterday, right? So you say, okay, we'll let u be this x cubed minus 1. And of course, as soon as you say that, you need du dx. So I differentiate x du dx, and that's 3x squared now. So this was the first step from yesterday. Second step. Third step is solving for dx. So if we have du dx now, becomes 3 squared x over 1. We put that over 1. You get a proportion again. And with this proportion, you cross multiply. And when you cross multiply, right, you'll get du is 3x squared dx, but you can divide both sides by 3x squared, and you get dx being du over 3x squared. All right. So the most important things you care about are here and here. And you say, well, what do I do with those kind of things? Well, this is u sub. So this integral that you see in black becomes, okay, I guess let's try to move everything over if we could. You have x squared cosine of u. Now, what is dx? It's du over 3x squared. And you cancel that x squared here. So this integral here, you say, is cosine of u now du over 3, but you factor out that 3, that constant. It's in the denominator. So you have this 1/3 integral cosine u du. Now, this is everything that we were working with yesterday. But remember the following here. We're saying now you have limits now. Now, what that means here is x still is 0 here. And x is pi here still. You still have the limits to contend to. So all along, you still have x is 0. You still have x is pi. But you have a real issue here. This is x is 0, and this is x is pi here. The issue is this, that you have an integral in terms of the variable u, but you have limits in terms of the variable x. That's a problem here. Right? You can't, even if you were to integrate this, the question becomes what happens with the limits. Now, here's the solution here. It's kind of obvious. You have to convert the limits as well. This is essentially what you do. And you might say, well, how am I going to convert these limits? Well, go back over here. Remember what u was. U was right here. U is going to be x cubed minus 1. Okay, u is x cubed minus 1. And so what you'll have to do now is get a new upper limit. If u is x cubed minus 1, you get u is pi cubed minus 1. That's your new upper limit. And then here, the lower limit, if x is 0, that'll be 0 cubed minus 1, which means u is negative 1. So here's my new limits here, ladies and gentlemen. So you go down, this is the new upper limit, and then you have the new lower limit, and you have u, this is going to be u. And now we're able to do this integration question. So now Sort of. Now we just have this in terms of u. These are my u's here. So I just want to kind of really emphasize that we have to convert the limits, and that's all. And so this becomes 1/3 from -1 pi cubed minus 1 cosine of u du. Now find the integral. Everything's good now because the limit here is in terms of this u, not x. So this is fine. Now, ladies and gentlemen, find the antiderivative of cosine. Does anybody remember? Antiderivative of cosine. See if you guys are out there. See if you remember this. Thank you, Renee. Sine u. Mu is -1. Pi cubed minus 1. Good job. So this will be sine of pi cubed minus 1 minus sine of -1. And that's, you're kind of done with this. It's kind of it's an odd kind of question in some ways, you know. But you're pretty much done. Of course, these numbers are in radians, you know, so you're talking radian measure for this. But that's kind of it. That's just symbolically. Ideally, you do want to evaluate these, but we don't have to for this. So anyway, you're done there. And there you go, ladies and gentlemen. So that's kind of what's happening here with this kind of question here. So that's all that's new is convert your limits and evaluate. Oh, and thank you. We always forget that when nothing happens. Thank you. Thank you, Juan. 1/3 and 1/3. Yeah, exactly. Whatever happened to that 1/3? There you go. Yep, 1/3 is there. Okay, good job, you guys. So anyway, this is kind of a little bit of a cheesy kind of question, but I just wanted to start the morning with that. And now let's look at some more here. So I'm going to say here's the square root now of two plus 3x. And next is going to go from 0 to 1. dx. So remember, this portion here is the u. So you're going to let u be 2 plus 3x. That's our u. So this is x goes to 0, x goes to 1. This was 2 plus that 3x to the 1/2 dx. So as soon as you find the u, you need du. So differentiate this 2 plus 3x, and that derivative is a 3. Solve for dx, because this is du dx becomes 3 over 1, or dx becomes du over 3. So for u substitution, this is going to be u to the 1/2 now. du over 3. And now u becomes 2 plus 3 times 0 for the lower limit, 2 plus 3 times 1 now for the upper limit, because of the fact that this is the u. So we want to convert these limits as well. And that's all that you guys have that's new here, is converting the limits. So let's not forget the constant. We'll bring that out. U to the 1/2 du. Now the lower limit will be just simply u is 2, and the upper limit will be simply u is 5. Okay, now we're able to integrate here. 1/3 u to the 3/2 over 3/2, evaluated from u is 2, u is 5. 1/3 times 2/3 u to the 3/2, and we don't have to put u as 2 and u as 5, but we can. 2/9 u times u to the 1/2, evaluated from 2 and 5. Now remember what this will be, right? This is going to be f of 5 minus f of 2. So it's 2/9 5 times the square root of 5 minus 2/9 2 times the square root of 2. And I guess we can do a little bit more arithmetic. 10/9 square root of 5 minus 4/9 square root of 2. Okay, or you can factor out the 2/9, and you see sometimes the answer this way as well. They factored out the 2/9. Either would be fine. But ladies and gentlemen, here's a numerical answer. This is going to be an indefinite integral because remember, indefinite integrals have limits because the answers are numbers. Definite integrals do not have real numbers as answers. You have the family of curves, and that's kind of what's going on here. So the new thing is to put your value there for you. Convert the limits as well. So that's all that's really new here for us. One 6 1/3 cosecant pi x cotangent pi x. Okay, so just to emphasize that when they give you a function of x and you have your dx, these limits are in terms of x. So u sub, again, you see here, what's on the inside here? Well, you have that pi x. This is our u here. So we'll let u simply be pi x. And you get the du dx. Pi is a constant. So solve for dx, and you'll find that to be du over the pi, ladies and gentlemen. Okay. Now, let's do the substitution. Cosecant u, cotangent u, du over pi. Now remember, u is going to be pi x. So u is pi, and the lower limit is 6. The upper limit, right, that denominator is 3 here because this is my x value here. U is pi x. So convert your limits from x to u as well. We also have a constant. So factor out the constant. Pi over 6, pi over 3, cosecant u, cotangent u du. Now we want to, ladies and gentlemen, we want the antiderivative of cosecant, cotangent. So what do you guys know? What's the antiderivative of cosecant, cotangent? What's that antiderivative? All right, you guys remember that? Antiderivative of cosecant, cotangent. Should be minus. So minus cosecant. All right, you guys are saying it's minus cosecant. Good. Okay, good for you guys, right? Minus cosecant. It must be that if you guys are all saying that. Good. All right. Thank you, Karina. Thank you, Paula. Thank you, Renee. Or thank you, Juan. Right. Thank you, Jesus. Thank you, Renee. It's minus cosecant. Okay. Now these are the limits are in terms of u. So I'm going to do a little bit of a simplification here. Now, I'm gonna write it this way because personally, it is easy to make mistakes when you're dealing with these negatives here. So just be a little bit patient here and write that as f of pi over 3 minus f of pi over 6 here. Okay, so that's going to give us minus 1 over pi cosecant pi over 6. That minus the minus does make that a plus. I think it's worth doing the extra step personally so that you can remember that minus the minus makes that a plus. And then I would say, well, what in the world is cosecant, right? I mean, cosecant, I think that's a reciprocal of what? Isn't that the reciprocal of sine? 1 over sine pi over 6? 1 over pi, 1 over sine pi over 3. Okay. And then we have to remember other few things. So remember, cosecant's the reciprocal of sine. I would say to you guys, remember this special triangle here. Okay, this is the special triangle here for finding these kind of angles here. This is a 2, 2. Yes, this is a 2, but we bisect. This is 1, and then by Pythagorean theorem, the height of this triangle is square root of 3. So, you might say, well, why do we care about this triangle? Because we need to have these values here. So I'm looking at this here. Definition of sine, so pi over 6, that's 30 degrees. So sine pi over 6, if I bisect this, this is now 30 degrees. Sine, by definition, if you guys remember, that's sine 30. Sine is opposite over hypotenuse, so that's 1/2. Sine of 60 degrees now, because that's pi over 3. 180 divided by 3 is 60. Opposite over hypotenuse. So 1/2 goes here. Square root of 3 over 2 goes here. Okay, so double check, ladies and gentlemen. And this is 1 divided by 1/2, which will be 2, plus 1 over pi times 1 divided by square root of 3 over 2 will be 2 over square root of 3, right? It's the reciprocal. And I'm going to switch my order here. So I have 2 over pi square root of 3 minus 2 over pi, I guess. Or, we can factor out that 2 over pi if you wanted. And you get 1 over the square root of 3 minus 1. But you want to rationalize your denominator, I guess. If you sit there and you said, well, what did they do in back of the book? And I see this as a final answer. You might have that rationalized. Square root of 3 minus 1. So they rationalize the denominator. And then sometimes they go further here. Right? Because they write this as 3 over 3. And so you'll have the square root of 3 minus 3 over 3. Or you look in back of the book, they have 2, 3 pi, square root of 3 minus 3. So you might see an answer this way. But personally, either would be fine. I'd even accept an answer like this, in all honesty. All of these would be perfectly okay for me. But anyway, that's fine. So as you guys can see, you might have to remember a little bit of definitions from trig, but this is This is a problem that's kind of straightforward of integration, and integration is what you guys want to learn how to do because it's the basis of the next two courses here. Anyway, all right, let's take a look at another example here. You know, they might give you a little something here, something like this. Okay. So a question like this, if they give this to you, you look at this and you say, well, how am I supposed to do U sub? You know, you look at this and I'll say U sub? Can we even do U sub here? You know, the answer is you can't do U sub. So U sub question mark? We can't integrate by U substitution. Okay, you can integrate this. But ladies and gentlemen, I want to kind of remark about this. Maybe, does anybody happen to know anything about this situation? I wrote it down for you guys. It's in your notes. I discussed it. But this is where I'm going to apply this idea. This is your function here, right? The function they gave you here of x squared sine x over 1 plus x squared. Okay, so I'm going to have to ask you a question here. This is a function, and the interval is over negative pi over 2 to positive pi over 2. So it's kind of a little bit of a trick question here for this one, because you can't even use U sub. It's on the U sub homework, but you can't even use U sub. So they kind of trick you with this. And you say, well, how am I supposed to use U sub here? Well, you can't use U sub. Here's what you want to know. Here's what you want to ask yourself. Is this function even, odd, or neither? You know, f can be even, f can be odd, or f can be neither even or odd. Now, we know something about odd functions, if you guys remember, right? Over symmetric intervals, if your function f is an odd function, then the integral is 0. That's as if f is odd. Okay? That same integral over a symmetric interval is double if the function is even. Okay? And it's very simply because odd functions have certain symmetry properties. Right? If your function is odd, by the way, that's symmetric about, anybody remember? That's symmetric. What do they call that one? If your function is even, symmetric about the y-axis. This is symmetric about the origin, which means both x-axis and y-axis. So you might say, well, how do I find out if this function is even or odd? Well, go with the definition. F of minus x, we replace x with minus x. So that means I get minus x squared sine of minus x over 1 plus minus x to the 6th power. Well, minus x squared is simply x squared. Sine of minus x, we have to find what that is. Minus x to the 6th power is just simply x to the 6th power. So the key to this question really lies in, what is sine of the minus x? Well, that here is minus sine of x. because sine is actually an odd function. So altogether with that negative sign, we get minus x squared sine of x over 1 plus x to the 6, and this is minus f of x. What that means is f is simply an odd function. So that is the key here to this question. You have an odd function over a symmetric interval because f to the minus x is minus f of x. F is odd. And so the interval is symmetric because it's from negative pi over 2 to pi over 2. So the answer is 0. So their intention was to really, I should say, slip this by you. And that integral is 0. Anyway, so this is kind of a nice, interesting question that they gave you guys. In my mind. And then let's try another one. Zero to 4 x over square root. One plus 2x dx. This one, they're not trying to trick you. This is a straightforward U sub question. Right? I'll let that U be down there. This is my U. So let U be 1 plus 2x. du dx would be d dx 1 plus 2x, and that's 2. Du dx becomes 2 over 1. And solve for dx. That means now dx becomes du over 2. So we're going to now do the substitution with all of this, right? So remember this. You got u, you got dx. U is 1 plus 2x. So it's 2 times 0 when x is 0. U is 1 plus 2 times 4 because we have to accommodate the limits here. Right? Here, this is x is 0. This is x is 4. X over the square root of u. Dx will be du over 2. So let's double check here. Okay. So it looks like this integral will be 9 and 1. And what do we have here? You got this x, square root of u, d over 2. So does anybody know? You got this x here. Looks like it didn't cancel. So what do we do here? Right? Do you remember this? We go back over here. There's a relationship between u and x. If we solve for x, this is u minus 1 is 2x. U minus 1 over 2 is this x here. So this x looks like it's the same exact x that we have. 1, 9, not x now, but u minus 1 over 2 divided by the square root of u, which is 1/2. Okay, and that'll be here du over 2 now. So take a look at what we just did. This portion here is your x. Now you have complex fractions here. 1, 9, u minus 1 over 2. Right? I'm going to do a couple of things here. U minus 1 over 2 now. Let's do this. Don't forget, this is divided by the u to the 1/2, but outside we have this, well, not outside, we have this du over 2. 1, 9, u minus 1 over 2 times that u to the 1/2, but we already have that du over 2. So 1 over 9, u to the minus 1/2, 4u to the 1/2 du. So the constant of 4 is here still, right? So we're going to pull that out. 1/4, 1, 9, and then the question becomes here, you guys want to remember that there is no quotient rule. There's no quotient rule here. So what you'll need to do is some algebra. And the algebra they want you to do is u divided by u to the 1/2 and 1 over u to the 1/2. Distribute your division here with this u. And you might say, well, you got to put those limits. Yes. This is u to the positive 1/2 minus u to the negative 1/2. And we will now be able to do our integration now, ladies and gentlemen. So there was some algebra to do. That x did not cancel. Sometimes that happens. And, you know, we know how to deal with that. So u to the 3/2 over 3/2. And then now u to the, add 1 to the negative 1/2, that's positive 1/2 over 1/2. Evaluated u is 1, u is 9. 1/4, 2/3 u to the 3/2 minus 2 u to the 1/2, where u is 1 to 9. And if you like, we say 1/4. Here's what we can do. I'm going to do some fancy algebra here, right? This is u times u to the 1/2 minus 2u to the 1/2. U is 1, u is 9. So what I mean by fancy algebra, factor out 2u to the 1/2. And if we do factor out that 2u, this is what I mean. We're factoring out 2u. What we're left with is 1/3 u to the 1/2 minus 1. And we have to evaluate that from u is 1. U is 9. So let's kind of double check here, see if we're okay with that. And of course, that gives you 1/2 u to the 1/2. 1/3 u to the 1/2 minus 1. U is 1, u is 9. So now plug in your limits. Meaning, find f of 9 minus the f of 1. And that will be 1/2. 9 to the 1/2. 1/3. 9 to the 1/2 minus 1. Minus 1/2, 1 to the 1/2. 1/3, 1 to the 1/2 minus 1. If you wanted to see that left to right versus, you know, vertically, we'll try to do that. We'll try to fit it in. All right. Couldn't get it all in, but this is why I sometimes write this out so I can be very clear with my limits. You know, and so we do know 9 to the 1/2, ladies and gentlemen, this number is a 3. This is a 3. 1 to the 1/2 is a 1. So double check. 3/2. 3 cubed minus 1 minus 1/2. Looks at that, that'll be 1/3 minus 1. So double check. 3/2, and then we get that 3/3, which would be 1. So this portion out here altogether, this is going to be 0. This is gone because 3/3 is 1, and that's 0. So you have negative 1/2 now. Right, we're going to distribute. Negative 1/6 plus 1/2, or 1/2 minus 1/6. So multiply the top by 3, the bottom by 3. 3/6 minus 1/6 is 2/6. So your final answer, ladies and gentlemen, is in fact 1/3. So yes, what can happen is when you start to impose limits here, so you guys know, when you start to impose limits on this U sub situation, and really even if it wasn't even U sub, when you start to impose limits, you can do a lot of arithmetic. And I always joke with people, I say I never really learned arithmetic until I took calculus. And the irony is I'm not even joking, you know. Because you do so much arithmetic in a calculus course that, you know, as you see here, arithmetic with fractions, which is kind of analogous to doing algebra with fractions. Properties of exponents there, everywhere, and, you know, adding unlike fractions. I never learned arithmetic until I took calculus. But, you know, don't tell educators and politicians that kind of stuff, because then they'll just say, well, all you need is arithmetic to do calculus, and the answer is no, that's not true. Okay, you guys know what I'm talking about? There's politicians of the world. You need some algebra skills, you need some trigonometry, you need some math analysis before you can take a calculus course, and even then, you need to review all those things and go back and study that stuff. And you may have to review and learn this really in order to do the work. And, you know, you kind of live in a crazy world that thinks you don't have to do anything. And, you know, and I get to say something to you guys just as an old man, and just tell you as an old man here, that's a false world. That world does not exist. You will find somewhere, somehow, a price you pay for the things you do. And focusing on reading, writing, and doing your arithmetic, the fundamentals, you know, you could do anything now if you could do that. And you don't want to have a weak link anywhere, or you know, a problem with the armor anywhere. And that's kind of important to always master the fundamentals, master the basics. Anyway, ladies and gentlemen, let's try one more. Zero to one. One over x minus 2 squared dx. Okay, now, this is something interesting. I want you guys to notice something here about this denominator. That x can't be the value 2. You say, why? Because you have a vertical asymptote at x equals 2. This is an important detail. I haven't really did a lot of emphasizing this. You know, but the idea behind the fundamental theorem of calculus is that the function has to be continuous, right? So here's where x is actually positive 2. You have a vertical asymptote, and the curve, though, is in the family of 1 over x squared. So it looks like this, and I haven't really emphasized this issue because everything that I've given you has been something that you can apply by the fundamental theorem of calculus. Meaning the curve is in fact continuous over the interval they give me. So this is the interval from 0 to 1. So remember, you need a function that's continuous over that interval from 0 to 1 in order to actually use the fundamental theorem of calculus. And in this case, it is. But I want to point out that detail for you guys. Okay? If that wasn't the case, well, then you say, well, we can't integrate. And the truth is, you have to wait to Calculus 2 to see those kind of questions. You know, Calculus 2 answers those questions. Not in Calculus 1, though. Calculus 1, they give you some nice continuous curves over an interval, and you can integrate. Calculus 2, they say now, okay, what happens when things aren't so nice and you have a vertical asymptote over the interval from A to B? What do you do now? And then there's something you can do. But we don't get to talk about that till calculus 2. So with this question, we can do it. You're going to let u be x minus 2. Let u be what's in the parentheses. So we'll say u will be x minus 2. So du dx will be the derivative of x minus 2, which is 1, which really means if I solve for dx or solve for du, right? Solve for dx, du equals dx. Yeah. Du is dx or dx is du. Okay. So this integral, right, will be, don't forget what u is. It's x minus 2. So u is 0 minus 2 for the lower limit, and u is 1 minus 2 for the upper limit, and that's 1 over u squared, and dx is du. So this is the substitution we have to do. Let's copy that. U is negative 2. U is negative 1. That's u now to the minus 2 power. Okay, so now use your power rule. Negative 1. U is negative 2. U is negative 1. And again, this becomes minus 1 over u. U is negative 2. U is negative 1. So I'm going to write this again as f of negative 1 minus f of negative 2 to illustrate a point. Right? If you want to minimize your errors, this is very helpful. Meaning, you say, what do I do? Negative 1 over negative 1 minus a negative 1 over a negative 2. Right? So this is the thing you want to be careful about. There's a minus sign there. Here's the minus sign. Right? Here's the minus sign. But you also have that difference here. So there's your difference. And then, you have these negative numbers here. So I guess let's go back to a different color. Let's use orange and green. So sometimes that's helpful, Then we have to deal with this world of negatives. Negative over a negative is a positive. And then negative over negative again is positive. So this is 1 minus 1/2. And you could do this as 2/2 minus 1/2. Final answer, ladies and gentlemen, will be your 1/2 answer. So there you go. All the arithmetic, all the algebra. I didn't learn arithmetic. I didn't learn algebra until I took calculus. I didn't even learn trig until I turned calculus. I mean, I learned everything when I took my first calculus course because it does require you to have that knowledge. So if you do have to review, good. And that's kind of how this is done, ladies and gentlemen. This is how everything is done. So these are kind of the recipes for you to be successful in your life, is to make this a priority, do that review, put the time in, put the energy in, and you master the basics. And if you do that, you could do anything. If you don't do that, you'll have a problem down the road somewhere, somehow. And that's just kind of the nature of how things work. So anyway, ladies and gentlemen, I hope you enjoyed this U substitution discussion here. It's one of my most favorite processes. But hey, they're all my most favorite processes in some way. And, we're going to start to use these tools tomorrow, now that we know how to do some integration. So anyway, ladies and gentlemen, you might want to, again, get started on the homework. I'm going to update your homework. And in the assignment portion, we're going to update that. And remember, you do want to do that homework. It is still due. You don't want to procrastinate. That's the worst thing you could do. And, calculus students are famous for procrastinating. So don't want to do that. So I'm going to put the odds here. Okay, we're going to update that. This is our U substitution here. That's still due on Monday. Okay, so you guys want to learn how to integrate and then focus on the last things that we have to do the last week. So ladies and gentlemen, you know, I'll probably do some modification. We'll see what happens. I'm going to do modifications for the trig class. Maybe not some modifications for you guys, but we're going to see more how to do the other questions tomorrow and then starting on Monday. So there we are. You want to integrate, ladies and gentlemen. So we're out of time, and, print your name in the comments section. And thank you guys for attending. Thank you guys for being awake. Stay safe and take care. And we'll see you guys tomorrow, and we'll apply our integration techniques.